So now let us look at how each of these robotic arms can be used to position. Now, if I first look at this Cartesian, we know that in Cartesian, any point is represented by x, y, z. So x, y, z, how do we position? So let's look at this particular diagram of 3D frame where XYZ is the reference frame, fixed frame, and NO is the movable frame. Now, if I am going to, you know, consider this particular axis and I am going to move it in XYZ direction based on a particular value to reach P. So let me take, suppose this is the value P where I have to reach. So first I will move in x direction a distance Px, and then I will move forward in y direction, let's say a distance of Py, and after reaching a particular distance of Py I will move in the z direction to reach, let's say, a height of Pz, so that I reach a point Pxy. So how do I move this? It's very important to understand how we move it so that we are able to see it move. Okay, so just hold on. Okay, I have selected it. Now this will move in Px direction like this. Then it will move in y direction a distance of Py, and then it moves in the z direction Pz distance, and then it reaches here. So the motion has happened in three different motion. One is in x direction, another is in y direction, and the third one is in z direction. So wherever it is moving, it is moving parallelly to that axis, and because of which there is no rotation that has taken place. So if at all I have to write the movement or the transmission matrix with respect to r of the frame P, so that it reaches Px, Py, Pz, then I can see that it is basically, translation of the Cartesian robot, and that will be translation in x direction, translation in y direction, translation in z direction, and that will be pre-multiplication. And based on that, if I am going to find out, you will find out that the matrix will come out something like, there is no movement in rotation, so it is going to be 1 1 1, so 0 0 0 0 0 0 with a scaling factor of 0 here, and the last one we are having Px, Py, Pz. So that is how, for a Cartesian robot that we have here, for a Cartesian robot, the forward and inverse kinematic equation for position based on the first three joints is based on this particular equation. I have not written up the wrist yet here. Wrist we will see in another section. Now, just like Cartesian, we will have for the case of cylindrical also.